Hello and welcome. I'm Bill Wake. We're working on a basic interpreter written in Swift, and we've gone a long ways, but one of the things we left for a long time was output. Originally, output was kind of a functional thing. It was kind of the output was whatever the interpreter did with the existing output and new output it added, returned as a value. We've switched so that we're passing in something that's more like a stream where you can append to it. It isn't an actual stream, but it acts like one, I guess. And we don't use it yet. We just got it passed around to all the tests and all the calls on the interpreter. So today I'd like to focus on getting that thing in use. I don't know how incremental this will be. We'll see what we can do. All right, I just ran the tests a few minutes ago, so everything's green. That's good. And we're an interpreter. That's a good place to be. Let's find that. So what we changed was, at this point, the initializer for the interpreter, it used to just take the program. Now it takes an output as well. And I almost want to call it outputter. Actually, it's probably going to be an interactor because it's probably going to do input and output at some point. But at any rate, we just set that aside. And then when you call run, let's see, here's step. Each step is going to take that output as part of it. Oh, wait, I'm mixing them up already. We have an output variable, and step takes that output string and appends to it and produces the new output string. So this is the main interpreter loop. Find the next location, parse the line if necessary, and then repeatedly make the new outputs a function of the old output and the statement. Okay. That's the piece we want to change. So rather than returning output, I would like to write the output to the output stream. And even though it's a kind of a moderately big change, I think we can just do it. I want to. Okay, let's take this one case. All right, so what I want to do is I've got my big output. Let's change this to outputter for a minute just to make sure we're not stomping on our own toes. Okay, so right now it's there. Nobody does anything with it. We saw it was just referenced once in the setter at the setup time. Okay, so right now, let's go to the REPL. REPL is what runs it. Okay, and the way REPL works now is it gets that output from the run and appends that, which appends it to the output. Okay. Now that. Okay, interesting. We've still got pieces of old output around. Here's the real one. This is this new object output. It's observable, so our user interface can use it. And when you append to it, you're just appending it to that string, but it's marked published, so the model view mechanism, it sends a little message basically, and the view is then notified of the change and can redraw. All right, let's see. So I would like to find a way to. Yeah, I kind of want to push things down in a sense, right? So I've got output here. I'm willing to let outputter just be a global for now, or a field. And there's only so many places that do this, right? This one does. This one just leaves output alone, so I don't care about that. define just returns output. Most of them do, because most statements don't print. Okay, only if something goes wrong in an interpreter error, then something will get caught somewhere and written. But in most cases, um, output is just carried through. These two are not. Do print and do if. Do if, because those statements might be print statements, and so it could be printing. Let's see what do print does. Okay, returns result. I'm inclined to say, can I just output it right here? Okay. How will my assertions know? All right, let's find a test. Well, let's just maybe take one at a time. I don't know. Check program results. Okay, so this gets the output and asserts it's equal to the expecting. Let's add an assertion. Let's assert that outputter.output is equal to expecting as well. Okay, so lots of tests are going to fail now. Maybe like not all, but lots and lots. So they get cracking here. Okay, yeah, most of the interpreter tests fail. Okay. Let's just take them. Okay, so the assert failed. Everything's blank. Okay, so let's. Oh, it has hello. Which is true. Let's add that. Okay, we had 59 failing. I think if we do that, hello new line plus expecting. I'm not sure this is the best possible way to check it, but I think to move forward more quickly, I think we'll do it this way. Okay, we got rid of one failure. Yeah. Okay. Hello new line is not equal to hello new line. Because print doesn't do anything yet. Okay, so I think let's try making print. It's got the result there. Let's have it append it to the outputter. Result. Okay, so prints do their job. And print is the most, I mean, that's the heaviest, well, it's the heaviest use of printing. Most of the output is from prints. There is some output from errors. Okay. 135, 135, 136. Okay. So an initial output got in there. That's really odd. This one I can believe we don't catch errors. So I think who is printing that? I think it's because we are returning it as a string. Let's take that part out. Return output. Hmm. I'm. What do I want to do? I'm kind of thinking what's going on is because we return output here, um, whoever calls run. How is that? Let's see which line is failing. Maybe that's. We'll just run this one failure. Okay. It fails on this. That's not the one to go to. Errors are not ones to go to. This one, 25, 25, 50. Okay, let's try this one. Okay, it shows the last failure in here. So, oh no, it doesn't. It shows them all in here. Well, it's like a double hit, right? Output equals. Hmm. Okay, I'm puzzled. It's printing that first one twice. It's let's return an empty string here. I think tests will fail in their first assertion now. Okay, yeah, they'll really fail. Print rand 0. Okay, well, that's clearly not going to work. Let's try outputter.output. Okay, that one's okay. These. Oh. A little too fast on the T key there. Found nil. Oh. Maybe this hello is not a good idea. Okay, let's deal with that. Let's start it empty. Somebody else can put it in there if they want it. And maybe somebody may complain, but let's see what that does. Quite a few failures. Okay. Right. Oh, I got to take it out of my assert. Yeah, the problem we're having is because I wrote my tests at a little higher level, in the sense that I'm using the print statement. I'm interpreting the interpreter tests are interpreting. Um, they're running small programs to do their job. So I'm coupling the the parser and all that stuff mechanism runs. So I'm not just checking the internal structure, what does the interpreter do, but I'm checking what does it do programmatically, and I think that may be part of it. Um, but maybe there's something else going on here. Okay, let's run this test. Okay, and what can I put on these? Expression message. Okay, let's I don't usually put messages on these, but we needed it. Okay, and pretty sure it's the new way. No. Okay. Oh, yeah, because I took out all those prints. Let's take that out of the assertions now. Okay, that's a much better number. All right. Syntax interpreter. Okay, error messages. Yeah. Let's look at the interpreter on those. I think we're just kind of to the point of um, just moving forward on them and seeing if 20 tests we can handle that. So let's put outputter dot append, and we'll just get the message. Okay. Anybody else? Well, an error. Where does that get caught? Run throws. Okay, so I guess the REPL must catch it. Yes. Okay, and it appends. All right, so it should get that. Right. Let's run this. So much for that theory. Okay, empty is not equal to error. Expected start of expression. Syntax error stops interpreter. Okay. Let's see. We're calling run. I thought our error was this. Let's break here. Okay. We'll step over. Message is. Oh, let's just print it. Not as helpful as I thought. Okay. Okay, error expected start of expression. That seems to be what the outputter has. Let's return. done. Okay. All right. Oh, we didn't look at outputter here. Okay. Good. Check program results. This one puzzles me. Why is there an extra 135? Only on the first line. Okay, that's a clue, right? How are we treating the first line different? Oh. Well, I don't know. Let's go down. Let's go to do print. Okay, so well, let's break here. Let me see. Maybe some of these others. Check program results. Oh, that is an interesting one. All right, because that's in that main interpreter loop. So my theory is I'm going to take an easy first pass. Any obvious ones we'll fix, then we'll have the hard ones left. Okay, so that error comes from the middle of this loop. Yeah, we return output, but we should write this to the outputter. Good. Statement 1, 2. I think this one's a double print again. 25, 25, 50. That's an if. 25, 25, 30. 25, 30, 50. 25, 25, 30, 25, 30, 50. Okay, we're picking up the output as it goes. So it's appending something rather than just returning the one thing. Yeah. Okay. This is going to be more of that for GoSub. Yeah. Okay. Let's go down to print. Result equals output. Okay. Let's return output plus result and start result empty. Okay, so now result will be the current result, and then the outputter just gets that, but the old one accumulated it. All right, so I'll run this batch again. Good. Okay, and these may be at a different level. 10 print 42. Oh, we lost the hello. Um, I have taken that out. Of the REPL. Yeah. I think that should be gone. I probably want to print it at some point, but I don't need it to be part of the stuff printed by the tests. Okay. All right. Everything prints to the outputter now. Outputter now. So returned output string is now ignored. Okay. And again, the problem was the way we were doing it, it computed the whole output, for the whole program running. It just accumulated all the output. And then at the very end, at the end of run, it returned it here. It would just return output. And now you had this whole big string. But that's not interactive, and we want to be able to make this thing interactive. Even though the original BASIC, this was adequate because there was no like input statement where you could type anything into it. It was not an interactive language. That came later, more like in the 70s, maybe in the 60s too. I don't know what happened after 64 when the version the spec I have was written, but the accumulating all the output is okay if you don't do inputs, but if you're going to be interactive, you'd like to be able to do this as you go. And I think even if you're not interactive, if you had 10 print something, 20 go to 10, and just this infinite loop, it would be nice to see it printing as it went rather than waiting until that was done. So we're eliminating that now. All right, excuse me. And so I think we should be to the point where we can eliminate all these return value strings, and the consequences of that will bubble through. Okay, so return a string. Okay, we don't need to do that anymore. So let's take this off and see who complains. Besides this last line. Okay. Yes. Somebody calls it and okay. Oh, good point. Okay, I'm still doing that. Card body must not fall through. Yeah. Okay, we'll just do a return. It's harder than I thought. Okay. Do run. Well, now do run has the outputter it's written to, and we capture this here. Okay, we don't need to capture that anymore. And let's just do this. Okay. All right, and see who complains. Okay, so interpreter, let's lock this one in. So we don't need output. All right, I'm going to make this be nothing equals try. We have this. Nothing equals try step. And we'll drop that return. All right, and then we also touched REPL. We'll do that. Okay. Oh, okay. just make that arbitrary. Hopefully nobody still needs it. Good. Okay, so we've eliminated it from step or from run. Eliminate return string from interpreter.run. That's not really a static method. Okay. Now we had a bunch of warnings. Okay, and let's handle those. So we don't need the old way anymore. So we don't need the message anymore. And this no longer creates an output. Okay. All right. Okay, now step takes an input. We don't need it. Okay, so let's remove this parameter. There are a number of places that use that call step. I mean, there are a bunch of tests that do, not tons, but there's a few. Okay, so I'm just going to replace the parameter with a local variable. And yeah, I guess it probably isn't changed. Okay. So let's deal with the consequences of removing output from step. The run, we can get rid of this part. And down here. Okay. Now some tests should complain. Really? There's not one test that... Yeah, okay. There. And I'm going to be touching these same lines again when I deal with the fact that they don't have a return value, but, you know, little piecewise changes I'm pretty happy making. Okay. Okay, and well, let's go to step and take care of its output value. We don't need to return a string now. Okay, so that goes away. That goes away. Because it's a case, it's just going to fall through. We'll have to deal with do if. And print when we get down there. Okay. Let's pass in an empty string. And we don't need the return anymore. We'll catch the value like that. Okay, and we'll do the same for print. Break. Do print. The output is empty. We try it. Okay. Oh, I guess I can catch it. Actually, I'm better off with the warning, aren't I? As long as we remember to go do it. Okay. Interpreter.step. No longer has output, so we got to go to the outputter. .output. Okay. Good. Those are okay. Let's check this one since we modified it manually. Or ad hoc anyway. Good. All right, so we remove output value from step. And that's a refactor as far as we're concerned. It's a little bit of a manual one, but that's okay. All right, now we got these warnings because, well, let's start with do print. It returns a string. We don't need a string. Yeah, we don't need a return value. Okay, so here we don't need this. Okay, we still take an output argument. We'll get rid of that too. Okay, so make do print not return a string anymore. And we can get rid of this parameter. We don't reference it, so there's going to be some people breaking because they call it. Not a lot. Do print. Okay. And let's see how it looks. Okay, build a result. I don't think that's really. This is really printed output plus new line. Let's just do it that way. Actually, let's just put it to outputter. Okay, so now we don't need these two. We don't need this. Okay, so we print its arguments separated by spaces and okay. I don't know what format is. Oh, format's a value. Okay, good. Okay, so I'm happy with do print. Let's make sure that. And then we also had the do if, something like that. Do if, right. Returns a string. We don't need to do that anymore. And this goes away. Interesting. Where's the statements? Interesting. I don't see statements being used in here. I don't know why. I guess the if it just if it fails its condition, it jumps around them and then it just lets them fall through. So okay, so let's take care of this first. Should be some people complaining that they call do if and it returns a value they don't want. Oh, we might be okay there. Yeah, we took the warning, so now the warning isn't applying. Okay, so there. And then expression is used. Oh, output is not. Okay, let's eliminate this argument. And this is, I think Michael Feathers maybe came up with the phrase "lean on the compiler." Maybe it was kicking around before, but I'm make the change and then knowing that the compiler will tell me about it. If it were one that was kind of silent, I would not want to do it. You know, if it just nobody complained, because then I wouldn't know where my call sites were that touched it. Okay. Now, this is interesting to me that the statements is just not needed. Okay. I guess it's just a consequence of the way we step through our program. So if you had if statement followed by statements, I mean, they are not used. Okay, so let's take them out. All right. Build. Yep, just that one site. And if we don't need them there, we don't need them here. It's nice to see complexity fall away. It's a little surprising to me that that is there, but I guess what we're doing is we're relying on that implicit flow that says we just keep marching forward through a statement, a multi statements on a line. We just march through unless we jump out for some reason, and the if basically just jumps out. Okay, let's see who else returns string. If anybody in here. Okay. Interpreter, basic format. Yeah, that's going to be a string. String function, yes, returns a string. And format is formatting a value for printing. And that certainly seems like it should return a string. Okay, so I think we've cleaned up all that output stuff. Let's look for the word output in here. We're going to get some kind of false hits because of outputter, but I don't mind seeing those. Okay, do print, certainly print stuff to the output. Outputter, we track it. Error messages go there, error messages, and we're back around. Okay. Um, I think we're clean. Yes. All right. Ooh, I'm happy. What I expect will happen is when we add the input statement, I think our printer becomes our outputter becomes an interactor and is prepared to deal with the input and the output side of things. So it makes a lot of sense to me that the interpreter has to know what kind of thing it's interacting with. Alrighty. And I think we are done for now. Actually, I think this line is redundant, so I'm going to see if anybody cares if that goes away. Okay. Where it might become more of an issue is if we support, there's a stop statement that's kind of like a pause or a debug breakpoint, and you can run till you hit the stop, and then you can say continue or something equivalent, and it picks up from there. We'd have to make sure that I think we're going to need another variable for that, but uh, that's the only one I know that might cause that there. But since we're returning and nobody's going to call run twice on the same thing, then I think we're okay. We're certainly okay for now. All right. Well, it's as good a time as any for a break. So let's see. Let's catch what we did. Make running right to an output stream. Okay, that's the big deal for the day. Good. Okay. Should number take a value instead of a float? Well, that's a good refactoring question we had. So we'll come back and tackle that. The real thing I want to do today, though, let's run the amazing maze. Okay. I don't know if you've run across this program. I saved it somewhere here. Yeah. Um, it's an old program. I don't know. Does it have a copyright year? It's like 1980s, early 80s, maybe earlier. It's one of the ones there's a classic collection, Basic Computer Games by David All, and this is one of those in there. Um, Mine matches. I think I've got the right text to my printed copy. The only exception is um, their basic allows the same name for a subscriptive variable and a regular variable. So I we don't do that in ours. So I changed the name of this one to V0 instead of V that the original had. But what I want to do after we get back, well, I want to do that refactoring, but then I want to try this program and just see how far it gets. I know it's not going to go far because I don't even think we support. I don't know if we support tab, but we definitely don't support semicolons in our print statements yet. So it won't take long to blow up. But this is real code. It's I don't know what that is. It looks like 100 lines, maybe a couple hundred lines. It'll be fun to see how far we get. I think we almost can do it. We don't have an input statement because the old basics didn't have that. And I think the semicolon on the print, I think, is the only other thing I saw that looked like it might not work. So we will next. So we'll come back. We'll do this, which will only take a few minutes. Then we'll see what we can do on the amazing maze, and that'll tell us the couple of things we have to do to make that run. And we'll implement those, the print and whatever the other one was, and go from there. I think it'll be a big milestone to run this little maze program. It's very cute. And if you get a chance to look at it sometime, it's kind of insane. Like every line is if something goes somewhere, if something goes somewhere, if something goes somewhere, if something goes somewhere. And then down in the bottom here, it's like, okay, now print it. And everything comes out amazing. So, all right. Anyway, we'll take a 3-minute break and tackle what we need to get further. But I'm hopeful we can do this. I mean, it's a big thing to throw at it, but we'll take it in steps. So, see you in about 3 minutes. Hey, welcome back. All right, so this question, should number take a value instead of a float? Let's find number. I think that may be a parse thing, right? Yeah. Okay. So, um, the reason it's a little bit of a problem is um, we pass in a float now, and our program manipulates values. So value is kind of a parent type for float and string and other entities, so that we can um, let's see, where's value? Well, we don't need value. We need the mapping, the interpreter. So in our store, which is where we keep all our variables, it's named to value. So some variables are strings, some are integers, some whatever. I guess they're floats, but yeah, they're values. And we have places where we have number. Um, See how we're always doing like as float, as float, as float, as float. I think well, that's coming. These are values that are coming in, and then number wants a float. So I don't know. It's almost worse in a way. We'd convert this. We'd have to say value here. So I guess we're deciding if it's worth it or not. Um, the values definitely have to be converted. Now, right, because some functions. Well, okay. I was going to say some functions work with floats and some work with strings, but that we're not. In the long run, we might allow plus for strings to append strings, in which case this would be have to handle those cases separately. Um, but evaluate function. I don't know. Maybe it's not worth it. Let's find as float. I think the for loop needed it. Is this for loop index for? That's multi-dimensional arrays. This is the for loop. Yeah. So we have a value. We convert it to float, so we can store it as a number, which can go in here. Those would get simpler, but I think a lot of other ones would get more complicated. So maybe this isn't worth it. Does next care? Yeah, there's this again. Step size is float, so number can store it. But then I'm also not sure where value is declared. Let's find. I guess I can just open value. Values. Okay, it's defined at the interpreter level. All right. I think we'll skip this refactoring idea. I think on net it's going to add, it's going to take away. It's not worth bothering with. All right. Let's see what we got here. Okay. So if I just take this program, I'll take the whole thing, and we will run our REPL and see what happens. I don't even know if it'll let me just paste like that. Okay. Let's see. Okay. It's happy. Okay. So you can imagine what it was like in 1982 getting this in your magazine, Creative Computing, and go sit down and type it in like that. It's a good way to learn, I think, but it's a bit of a pain. Okay, run, error, extra characters at end of line. All right, so that tells me our error messages are really not helping. I think the character at the end of the line Well, I don't know if that's end of line. We don't know what line number it is even. Okay, so issue one. Let's see. Where'd my Xcode go? Oh, have I maximized it? Sorry. um, ignoring all your chats, but there weren't any. Okay. I suspect. Well, I sure think semicolon's not legal here, but that message makes it sound like end of line. I'm going to put this on here. Okay. But this error, this is just the primitive way of printing it, right? It's not giving us much. Excuse my clock. I don't know how I can. Well, okay, I do know what I can do. I don't have a reset. Okay, let's catch things. So, run the amazing maze. Well, what we find is error messages don't tell us where the problem is. We've got stuff in there for the line number at least, and really the character in some sense. Okay. Semicolon not supported in print. Okay. What we can do is I can stop running. I'll run again, and we'll do it piecemeal. Okay. And if we run extra characters at end of line, okay, let's change this. Let's make it like this. And run that. Boom. Okay. Unexpected nil while unwrapping. Predefined function. Oh, name is tab. Okay, we don't support tab. Good to know. Doesn't support tab function. Okay. We'll stop. Okay. I mean, obviously, we're not getting too far down, are we? Okay. Let's take the whole thing. Well, I know it doesn't support the input function either. Okay. Let's. Okay. I'm just going to muck up the ones I know I can do. Okay, so let's delete line 10. It's just printing, who cares? Delete line 20, it's printing, who cares? If I do a list, I thought it was supposed to list it out for me. Maybe I gotta read up my REPL. Command equals list, do lists. Okay. Interesting. Okay. Well, hopefully line 10 and 20 are deleted. Let's see. In line 100, let's just make it assign it a height 10, vertical 12. And where else are we going to see problems? I don't know about that dim statement. I don't think our dims handle multiple ones per line. Okay, so let's assign, let's break that one up. 110 dim WHV dim V0 HV. Oh, sorry. Okay, and that should get us down a ways, probably down to 171. Let's run. Do we get anything? Error integer dimension size required. Oh, okay. Um, that's a good thing to know. Dim should allow multiple declarations. Dim should allow variables in dimensions. Okay, that's probably expressions, right? Okay. And we can override that. We'll just say dim W 1012 dim V0 1012 and run. Okay, and nothing. Okay. I'm really worried that list isn't listing. Okay, so let's. I don't know if these really got in as independent lines. This could be one giant line for all I know, but it should still have listed that, shouldn't it? Okay. Let's see. List doesn't work. It didn't work. All right, let's stop it. Run it again. We're getting quite a punch list here. All right, so if I just put in 10, print 10, and 20, print 20, run it, it should run, and list it, it should list. Okay, so what's the difference? I think is it paste that creates a problem? Let's take these two. Huh. Now it's okay. All right, let's take a bigger chunk. Okay. How many lines I got? 140. Let's take half. Okay, yeah, something's right. So we still have the 20 and 120 and 130 that we originally had. I think this is the whole thing is treated as line 10. Okay, so basically the REPL I didn't think about pasting in. I just assumed you'd do it one line at a time. We were just imitating the old style on this. But that's way too handy. So I don't know why it didn't list it the first time, but there's definitely something. I mean, this line 10 through 590 is all one big line in the way it interprets that. Let's see the REPL. Execute command of string. Boy, it's really a bunch of stuff, isn't it? Okay. Well, this, yeah, let's just say pasting multiple lines doesn't work. Okay. How can we do this? I guess it would be handy for us to have that work because I want to be able to just paste this amazing.base again. I clearly don't want to type it every time. So let's rework our REPL a little. Error messages tab I'm not so worried about. I guess if I want to move things up, I want to move this up. Really that, well, let's move it. Okay, our error messages. I mean, I think we have the information. We should at least tell you what line number is messed up. Okay. And we've certainly done this. Well, maybe it's attempt rather than run. Attempt to run the amazing maze. Okay. And we'll pick up here. Okay, so let's look at REPL. Oh, look at this. We got old output still. Anybody else? Okay. All right. Delete unused old output in REPL. And REPL is read eval print loop if you haven't run across that one. Okay. Let's see. So I think what we're saying is the command that comes in could be a multi-line string. And so I think command.count. Oh, if it's an empty line, okay, yeah. I think what we want to say, and I don't know if how thoroughly we test this. Okay, we've got some. Okay, so I think what we can test this. We can say test multi-line command executes each one. Okay, so if we were to do this, 20 print 20. Print 10 times 10, print. Actually, I'm okay with that. All right. Contains 10. Okay, that tells us the program contains a certain line. So let's check Um, REPL sub 10 should be 10 print 10, and REPL sub 20. I think we got a subscript on it. Maybe we don't. That may be why I didn't bother with these 20. But I think it seems fair of us to ask. Whoops. Okay, has no subscript. Okay. Who calls this? The tests. Okay. Then I think we're going to say this is a testing capability. And I'm going to make it an extension thing. All right. So the way I do that, we're going to make a new class. And you can say REPL plus something. I'll just say plus test. And okay, so we'll make an extension on REPL. Add this in. And our tests, these two lines are still not there. All right, let's do a clean. Okay, and then run this. Whoa. REPL has no member contains. Have I done this wrong? I have another extension. Cannot find type REPL. Oh, okay. Think. Good. Okay, so REPL tests. That should work now. Good. And program has index. We'll just steal it from there. We just need a getter. Turn program subline number. That seems good. And we'll make our test use that. Right, should fail. Yeah, okay. That's actually the right error, isn't it? So it stored line 10 is 10 print 20, it was 10 print 10, new line 20 print 20. That's kind of the behavior we saw in running the maze. Okay. Now this is moderately a moderate change in here, I think. So execute. Well, I think this is like commands. Okay, and then this we're gonna say commands dot split separator new line dot for each do command in, and then all this is in the command. Cannot convert string subsequence to string. Okay, I just want to do that once. So let's let command equals string of $0. Okay. Okay, so we'll take all those commands. For each one, we'll do this stuff. Okay, and we'll just run tests. Good. Let's try it. Where'd my basic program go? I lost it. Okay, now I do this, and I'll say list. I should get, oh, there it is. Okay, I just don't go to the bottom. It's okay. I guess it's a Swift question for me. How do you force the display of the bottom of that thing? Okay, so let's delete something. If we type 1041 without any text on the line number, that's the same as saying delete that line number. Okay, and if I list, I shouldn't see a 1041 there anymore. No 1041. Okay. Yeah. All right. So is this a browser window? Sure. So let's say Swift UI force display of end of text field or something like that. I know there's a way to do it. It's display end of text, maybe. This, I think there's like a, oh, they've changed the look of this. Okay. I think there's something, one of these modifiers that lets you say where to display it to. Multi-line line alignment. Text is a big thing. Okay, let's just try doing it in here. Text dot. scrollable. Like I said, it's a big class. Alert. Focus scope. It's not focus, I don't think. Well, I thought this would be faster than searching, but it's a pretty long list. Position. Nope. Well, I didn't see it. That's what I want. To scroll and scroll view to a particular item with an ID. Yeah. Yeah, the ID we don't, I mean, we just have a string, so there's no particular ID, I don't think. Scroll list automatically, but it doesn't really say text. Maybe I should just. Nope. Stop. Okay, what did I do here? Nothing. I don't know how to force it. Maybe it's on scroll view. Looks like a similar sized list, doesn't it? Okay, let's get a new search window. Whatever I did was not right. All right, scroll view Swift UI. Good, that's what I wanted. Yeah, I've done it with this approach where you put IDs on things and you can say scroll to ID. Um, Scroll to bottom. Only on change. Maybe this answer is a scroll view contains a scroll view reader on change of entries dot count. Button proxy scroll to. I'm going to let it go. We'll just edit as a wish list thing here. Okay. So what we did was REPL supports pasting multiple lines, executes each one. Okay, and I think another idea would be REPL should automatically scroll to bottom. And maybe something like this can work. I could put some invisible marker point at the end of after my text, and then force a scroll there sometime. It's not the button, but something I'll have to do it. So I think it's a doable thing, but I want to move on. Go figure. All right, error messages. Don't tell us what the problem is. Oh, all that work to put error messages in. Okay, let's catch this. Make REPL handle multiple lines in a command. Good. Okay, error messages don't tell us what the problem is. Well, let's see. So, an example again. Whoops. Oh. Guess I didn't run tests, huh? Okay, I don't mind. I'll trust myself for a new line, but sloppy. Sorry. Okay, run this. If I say 10 input X, which we don't support, and I run it, I should get an error message. Unknown statement. Okay. So the error message, I think, is coming from interpreter. We had an error case. Yeah. Outputted at append message. Well, let's see this thing. Parse error. Okay, parse error. What happened to the line number? Um, I thought our parser. Just go in one of these and find this. Okay. Message is just the message. Okay. Well, our tokens, and that's token type. Where's our token? So the parser knows the token. Wow. I thought we had dealt with this. Okay. All right. So here's token. Token knows its line and its column. The column isn't the true column you typed in, but it's the sort of squeezed out column. Basic ignores spaces not in strings. So it's the column that the parser sees. But this should be part of the error message, and it's not. And the question is, do I want the token or the line number? Okay. Error, parse error. Well, I can. It's a little confusing that the enums have the same name. I've done that a number of places. I don't know if I like doing it or not. Well, I obviously like doing it. I don't know if I like the result or not. But maybe the error is the place. This error statement error is the place we should have the line number and column number. If I add it, everywhere goes crazy, and I don't want to break it. Okay, so we're gonna do it. We're gonna do it stepwise because there's 50 or 100 places that have errors. Well, let's do a rename first. Okay, this we will rename to old error. Wow, there's only 12. Let's cancel that. What are all these errors that the parser's returning? Where were we? So I think the point where errors get thrown is the point where they know the location. They know the token they're looking at, and the token has that information. We don't want to carry the token beyond the parser. I don't want the interpreter to know about tokens. So, now parse error could. Okay, so I think let's give the token to parse error in here, and I think I'm going to switch this to knowing the location and a error string. Okay, so even parse error won't leak out beyond the parser. So let's add token here and see how many places break. Parse error does not conform to equatable. Why not? Oh, token is not equatable. Ooh. Okay. That was fast. Let's see, token. Well, that's not out of range token types equatable. I think we could make our token equatable. Okay, it generates it automatically, so it's not that hard. Okay, now let's see how many places break. Enum case in a public type uses. Like once you start going down the path of public, it really bubbles around. Okay, 23 cases. Well, that's not unbearable. Okay. And most of them are just going to be lowercase token. Okay. So I'm going to just fix that with token in here. We see that one a lot. Equals. Require, we'll deal with it. Well, I'm realizing there's probably a bunch of tests that need this treatment too, but yeah. Token type. Token is a token type? Wait a minute. Who uses this then? Next returns a token. Okay. The token. Oh dear, we don't keep the token around. Huh. Okay. Oh boy. Let's keep the token. this. I guess we'll call it the token for the minute. Okay. Yeah, I'm not really happy. I guess this should be the token. Okay, this is the only place we reassign it, so that should be okay. I will straighten out some names eventually. Parse error token, comma, becomes okay. Build failed one place. Error. Oh, that token is not in scope. Oh. This is in state. I think well, this is kind of a can't happen situation, so I don't need to be too picky, I guess. Yeah, theoretically this won't happen. Okay, let's see. There's got to be some tests that, yeah. REPL tests. Okay. Parse error. Oh, do I want to get into this? Let's see. Everybody's doing error. Okay. I don't think I want to deal with the locations on this. Okay, so what I'm going to do, see if I can do this in one place. I'm going to make a string here. Output parse.line, parse output to line number, error expected. I'm really just trying to check that the first entry has the expected error message. So let's get actual message equals, well, it's output dot statements sub 0 output dot statement sub 0, and we know it should be an error. Closure expression is unused. What have I not done? Guard case. Okay. Now I've got parse error. Okay, so let actual message equals parse error. Oh, okay. Got to do the same thing again. Ugh. Let token actual message equal parse error. Can I do that? Okay. Oh, okay. Okay. I've got an error in there. Otherwise, output statement 0 doesn't find it. Okay. So that much is true. Then I've got the actual message from the parse error. If I don't have that, well, it's really it can't happen. Okay. So I probably, yeah, there's probably a better way to do it. Okay. But at this point, I've got actual message, and I expect that to be expected. Okay, now everybody else is going to complain because check errors, I'm taking this out. I just want to make the message be the issue, which I think is a better expression of this test anyway. Okay. It's unfortunate I have to change so many places, but it was kind of on my list. Just the tests aren't as minimalistic as I like. Some of these, we may have a case that tests multiple errors or something like that, but I don't think that normally can happen. Also, we'll find out if I messed up the check error function. And unfortunately, I have to deal with the parens, so I'm doing these one at a time. And last time I tried the multi-line edit, it screwed up so bad. I'm just kind of hesitant. I think maybe the blank lines I had threw it off or something. I know, just editing. It probably would be okay. I mean, I could just zap out all those parse error.errors and let the compiler tell me where the missing parentheses are and go from there. But yeah. I mean, I'm definitely happier with the test. That it really is just like, here's the code, here's the error. Okay. And let's see if there's others. Okay. Miss one here. Okay, our error expression tests, did they have their own check error? Okay, let's... Okay. Can I do that? Oh, because they don't... I don't think we have to worry about that case, but okay. I'm going to duplicate this in this parse expression tests. That's probably a mistake. Okay, is that it? Okay, one case. I'm not gonna worry about what the error is. Let's just assert is there contains? No. Assert true. Let's say output dot contains and I'm just going to look this far, and this is going to change at some point as well, but even that. But error contains error. Okay. That's I'm making the test a little less particular, but I think really I just want to make sure that it comes back from the run. I don't care how it stores that error message really, but it's good enough for now. My hope is all the tests pass, and we can say parse error token. Sorry, parse error contains it. Okay, so parse error now contains the token. And I think, yeah. All right, so parse. Okay, so parse error contains the token. That's fine. This error, I want it to be different. I want it to return the line number, the column number, and the string. Okay, so this is the one I'm going to change. Rename it to old error. And notice this one's only in a few places. Okay. the parser, a few tests, and the interpreter is the big thing. Okay. And I'm going to add. Okay, so the new way is error takes a line number. I don't have a column number. Let's put it in a string. Okay, and line numbers here. Let's make column number. Okay, and when I build, somebody's going to complain about case statements not covering all the possibilities. Yep. Okay, let's add error. Line number colon column number, I guess maybe dash, maybe just message. And maybe the question mark doesn't need a space. Let's see how we like it. Okay, so I'm doing the same thing as this. Actually, maybe I should even just do the same thing literally for the moment. Let's get this worked in, and then we can get fancy. Okay. Right, we'll leave those warnings for now. Okay, there should be some tests that complain. No? Good. Build succeeded, test did not run. Okay. Nobody's referencing it, but we're add error with line number and column number. Nobody uses it yet. Okay, now parser. What we'd like to do is find the places that return error. Actually, old error. Because that's a lot less. Okay. Single line, try line. If line fails, okay, old error. Let's return error. Oh, it's more complicated, isn't it? Oh. Okay. I thought there was a way that I could say, like, some error token and message equals error as parse error. Is that not legal? Ambiguous without more context. that okay? And that error should be a parse error at this point. Yeah. I guess the thing is, there's this is this caselet thing again. Error of token message equals the error. If case. Is that legal? Error tokens never used. Yes, okay. All right. If error token, okay, so let me inline this. Is that legit? Parse has no member error. Okay, they're right. Oh. Why don't, okay, let's see the change. It was line number. Okay, so let's return a parse. The line number should be, I think error token is okay. And this is error of token dot line message. And it's multiple. Okay, and do I still have a flow that can't? Yeah. Okay, I don't need this. If it's not that kind of error, and okay, it's more complicated. These cases really do mess it up. But I think, okay, let's see. This should run. There may be a test that was looking for something a little different. Okay, there's a lot of tests looking for something different. Well, that one we can forgive. It's probably coming out like, ooh, that's too bad. I think this is probably coming out like this. Let's try that. Let's go even more minimal. Okay, now these error not found. Okay, can I tell in here? Error not found. Okay, I guess this is saying we found an actual error now. I think, is it if case? If case? Maybe I gotta flip this around. If case, old error, parse, blah, blah, blah. Then I want to do all this stuff. Okay, so if it's an old message, I want that stuff. I think else, if case error, and errors have line number, column number, and message. actual message. We don't need to do this stuff. We took that level out. Okay. And we can ignore these. Okay. Let's see how that does. So the old error, we're trying to make sure it finds the message, the new error, and then this is XCT fail, no error found. Okay, I think that's better. That'll help expression tests, and we'll have to backfill it into parser tests. Okay. And obviously this should be in one place. Expression tests, parser tests. Check error. Okay, and eventually this case will go away, so I'm not so worried there. All right, let's run all tests. All right, and I think we just did one place, right? Okay, so we've got this single line case, but it's catching messages all the way down, right? So this is a single line is basically the more or less the top level, I guess parse is, but you know, everything funnels through here. So if it catches any syntax error, it's got this, any error, okay, it's got, if it is a parse error, then it catches the token in the message and formats a nice error. If it's not a parse error, it's some other error, we're going to say, well, there was just a kind of unknown error. All right. And then, I guess who's using old error now? Maybe that's gone away. Okay. Let's see. Parse. See if anybody uses this. We know two places do. Case old error. Well, if it can't be generated. Oh, wait. Old error there. Okay, here's this one. At. Well, let's just return an error. And we don't need the token type. We'll take line 0, column 0, and statement too big. Okay. This test case, this test case. Okay. Okay, so the good news is we funneled everything through, almost everything through that case in the parser. Okay, it all funneled through line, single line. All right, so one exception of that sort of weird case that's kind of a can't happen. Okay, so now old error doesn't exist. All right, so we'll take that away. And then build should complain, yeah. Okay, we're going to get rid of this case. If the case there, and then this is kind of a fall through. Since we know this escapes, oops, has no member old error. I think it's just, outdated. Okay. And interpreter. That no longer happens. Okay. We should. Oh, 2 does. No? Well. Maybe I do need to return on there. And in parser expression tests. Okay. These. Yes. Okay. So all tests pass. Remove statement.old error. Okay, and then now I want to change this and see who breaks, if anybody. There's got to be at least one place. No? Oh, we changed that question mark thing. Okay. The interpreter tests. We only look to make sure that it has an error, start of an error message. Okay. And actually, this should be like 10 colon. There's 0, 1, 2, 3, 4, 5, 6. I think 7 is maybe it. Yeah. Okay. Expected start of expression. We'll see what the message is. Okay. Let's make sure that fails. If it doesn't. Okay, good. All right. So I think what we've done, we've successfully got numbers in our error messages now. So let's take that. That's a good win. Okay, so error messages. Now tell us line and column number. Good. All right. Let's see. Tomorrow I have a doctor appointment in the morning, so I won't be able to do my session, but I will be back on Thursday, 10 a.m. Eastern Time, U.S. to 12:30 p.m. or 3 to 5:30 p.m. UTC. Thanks for joining me today. I'm feeling really good that we're getting close to running that amazing maze. That's a big milestone, and I'm glad the error messages are better. We deserved that a long time ago. As we try and start running real programs, that's going to be more and more valuable to us. So I'm real glad we worked on that. Have a good evening, and hope I catch you in the future. Take care. Bye-bye.